All right. Where am I? I'm missing. Hello, everyone. How can I be missing? And I'm back. How exciting. Hi, everyone. How's it going from yesterday? How is everyone feeling? Feeling cooked? Feeling good? Ready to do more linked lists, I hope? We're going to keep cooking today. We're going to be deleting some stuff today, so it's going to get hectic. Again, I'll just preface with the first time you hear it might not be, I get it, I get it, I get it. It might take a few times to hear it. Don't worry, you're still doing stuff in your tutes. You're still kind of rehearsing these concepts and trying them out. So we're going to keep cooking. We're going to delete from a linked list today. We're going to search through a linked list. We're going to do all sorts of things. And then also I was thinking, just from the vibes of the last 2 days, people are kind of struggling a little bit and probably wanting to do a little bit more stuff. So next week, I'm going to do more linked list functionality just to give you a little bit more practice. And, you know, one of the best things is linked lists is like the last new content, really. So, and then we're kind of on the road to revising for the exam. And I'm going to show you what the structure of the questions looks like in the exam and how to like run the auto test so that when you get into the exam, you're really comfortable with the format of how the starter code is set out and what you need to do to be able to test your own code and so on and so forth. So don't worry, I've seen a few questions about the exam on the forum. We are going to talk about the exam in detail with all the information, and then we're also going to do questions that are structured like the exam so that you get to have a little bit of practice with how it all works when you get into the exam. All right, excellent. Let's get started. I thought today the first thing we'll do is we'll just do like maybe 5-10 minutes of theory. I'm going to run through the lecture slides to show you what happens when we're deleting from a node, and then we're going to get into it and then we diagram it out. So it's all going to be just the usual amazing vibes. Hopefully no one's falling asleep and everyone is feeling good. Okay, let's get into it. Yeah, it did just start raining, which, yep. It's all the good vibes. I didn't realize it was going to rain, but it's been pouring. Okay, I think Bree's shared the lecture code. She is right on top of things. So let's get into deleting from a linked list. So where can I delete in link? This is going to be another asterisk situation. Where can I delete in a linked list? So the same thing, okay? I'm going to be blue in the face and I'm going to keep saying it. You can always check when you write your code afterwards, test it yourself. Check something for an empty list, check something at the head of the list, check at the tail of the list, check between any two nodes, and you might even check past the linked list length as well, depending what happens, okay? So we'll talk about a few cases, but those things you should always consider, just those basic cases of dealing with an empty list, dealing with something happening at the head of the list, dealing with really struggling with words today, dealing with something happening at the tail of the list, and dealing with just a normal case where something's happening in a list that exists between any two nodes. And that's what we'll focus on today with our deleting. Okay, so the first case, if we're deleting from an empty list, okay, if we're going to do that just like we did yesterday with our inserting into an empty linked list, the thing that we have to do first is we need to check whether the list is empty. And if it is empty, then we just return the null, right? Because we haven't done anything and there's nothing to delete. There's no memory that we need to return back to the heap. We're done. The list is null. So you kind of, the usual way, exactly like we did before, you can check that the head is null. Here I'm checking that the current is null. It doesn't much matter which way you go, depending again on what you're trying to solve and what kind of fits into what you're trying to do. So in this case, there is no code past it, but if there was code past it, you just work with current just because, you know, easier. Why not? Oh, good. Literally updated my computer yesterday. Do not know why it's doing that again. So we're in for another fun ride. So I'll check if my list is null, which means is it empty? And if it is, I'm just going to return null. So I haven't done anything. I'm not going to do anything, and it's done. So then deleting when there's only one item in the list. So let's say I've only got one item and I'm going to delete it. Okay, so only one node. I've got a pointer pointing to that node, not a node, but just a pointer that's storing the address of this one tiny node. And I'm just going to free the head of the list, and then it is done. And then deleting when I'm deleting the head of the list, but there's a whole bunch of other items. I've just realized I'm also my oh, that's not what I meant to do. I meant to move the camera. Sorry, give me a second. Here we are. I'm just going to move the camera over to the other side. Okay, so if we've got a list already and we're deleting off items somewhere in the list, we do the usual thing, right? So we'll start, find the node that we want to delete. So let's say we're deleting the head of the list. So we're going to assign the current to the head. Then we want to delete this head, and we want our head pointer to be pointing to whatever is current next. Yeah, if that makes sense, because that's going to be the new head of the list. So the node after the head. So I will make the new head point to my current next. And after I do that, because after I've assigned the new head in, I'm going to delete that current node. So I'm going to free the memory that is associated with it. So if you remember, we kind of touched on free, but we haven't really used it all that much yet. And so when we malloc some space for a node, we have to also use free to give that space back, right? So malloc and free are both on the heap. And what we want to be doing is when we malloc something, we need to free it as well. So any memory that you have malloced, you need to free, because you manage the memory on the heap. Someone's asked, can you use previous and current instead of purely relying on current? You absolutely can. And we will also solve and in deletion, sometimes using a previous is, so much neater to keep track of what's going on. So we will solve a question using that previous and current to make it much easier as well. Okay, so we free the current. Now what happens if we delete, between two nodes? So let's say, for example, we want to delete this node with the number 3 in it. So we'll again set our current to the head of the list, and we want to traverse through the list until we reach the node just before. So if I go to this node, right, and I've reached the node with number 3 in it, what happened is I don't know what node came previously. So this is where this is really useful as well, right? If I keep track of my previous node, then I know where it is. But if I don't actually know where the previous node to it is. So if I delete this node, I can't connect this node to the one after it, right? So what I want to be doing is, if I'm not using that previous, is I'm going to be stopping on the node before the node that I want to delete. So if I stop at the node before the node that I want to delete, I now know the next node is going to have the 3. I can delete it, and then I can also hook up my current node to the one that comes next after the node that I've deleted. So if we're doing that, if I'm stopping at the previous node, right, I'm going to check that my current next data is not equal to 3. So I'm going to be checking always whether the next node to the one I'm on doesn't have the data that I'm looking for that I want to delete. And don't worry, we're going to write some code. I just thought useful to get the concepts out first, and then we will actually do the coding. And then I move along if that's not the case. And once I kind of see, okay, so here I've had current next data. So when I access my current next and data, I saw that it was 3, which means that I stopped on this node over here. So that means what I've done is my new next is going to be heading towards my current next. So it's like I've skipped a node over because I've gone current next and then next again. So I've connected my two nodes that were kind of far away, not far away from each other, but I've deleted the one in the middle. So I want to connect the previous one to the one that came after the node that I've deleted. And then I can free the node that I want to delete to release the memory back. And then, you know, I've got my next thing, which is my current next is the new next. So that means I've got this connection happening now as well. Okay, what happens if we delete in the tail? We want to be traveling all the way to the tail then. And again, we'll set our current to head and we will traverse through until we are standing, if we're standing at the last node, well, if I'm standing at null, then I've gone way past the end of the list, right? So I'm going to have some problems because I don't have anything going on. So do I need to stop, you know, at the tail, or do I need to stop at the one before the tail? So if I stop before the tail, then I can delete the tail. So I'll be checking whether current next is not equal to null. And this is, you can see that when you've got these next, it's really easy to lose track of what on earth is happening and where on earth are you, right? And that's why we're going to, that's why we will implement like keeping track of a previous node as well, because you don't need then this whole next debacle which keeps going. Okay, so then we free our tail and then we point our node to null for the, so in all cases, I'm going to sound like a broken record again. You need to check empty list, whether you're deleting at the head, at the tail, or just a standard between two nodes. So when you're deleting a node, find the previous node to the one that you're going to delete, change the next of the previous node, and then free the node that's to be deleted, and then consider those edge cases. Okay, so I think it's time now that I've done a little cooking, little simmering, let's do some coding, and we will write a little bit of code to get us going. How does that sound? Even if it doesn't sound good, it's happening. So yeah. Okay, so I think the first thing we'll do is just off the gate, before we kind of search through a list or anything like that, let's just do a little piece of code that will delete the first node of the list. Okay, how does that sound? So remember that we've got a multi-file now. So we'll go to our, how amazing. Oh, good. It's all happening here. All happening. I've lost a connection whilst I was. Okay, so if we're in our .h file, I forgot what the directories are called, sorry, even though I go into them all the time. Okay, good. Okay, excellent. So in our .h file, so our header file, we're going to define a little function that's going to delete the first node. Does that sound good? So let's have a function that will delete the first node off the list. Okay, who can tell me what we think is going to be the input and the output of the list? So we're just deleting the first node of the list, and that's it. And then we're returning something from that function. And what do we think we're going to return if we're deleting the first node of the list? What do we reckon? Yeah, so I'm going to output the head because I'm deleting the first node of the list, which means that the head is going to be changing. And yep, I'm going to input the head as well, because I need to give it where to start the list and how to go through the list. So everything is, I'm giving it the head of the list and I'm outputting the head of the list. So then the definition, our prototype is going to look struct node, and we're going to delete first node. And we're going to give it a struct node head also. All right, so if we've got this amazing, list, we're going to delete just the first thing from that list. The first thing we want to do is we want to check that the list is not empty, right? Because if we start to free memory that doesn't exist from a null, we're going to run into some problems, right? So the first thing we're going to do is we're going to check that that head is, if it's equal to null. Oh my God, thank you. Yes. Good chat. Good chat. Yep. I got overexcited. Okay, let's do this. Let's go to our linked list.c and let's actually do our function here. Good spotting. Okay. Okay, yes. Yes, look at that. Breeze answered it. So it's not banned. Typedef's not banned by the style guide, but we don't use them in 1511 because they abstract a lot of information when you're just beginning to code, which makes it much harder to understand what's going on. But you are free to use them if you know how to use them. Okay, and then you will learn about them in subsequent comp courses. For those that don't, do not stress. Okay, so the first thing we're checking is if head is equal to null. And then what did we say we're going to do if head is equal to null? So if the list is empty. So this is checking that the list is not empty. And if it is empty, then what will I do? I can't really delete anything from an empty list. Yeah, so I'm just going to return a null as well. So I can't do anything, list is empty, and I've moved on with my life. Okay, now I would like to, and someone said return the head. I could absolutely return the head because the head has null in it. So it's fine to do that as well. Okay. Okay, excellent. Next, sorry, I'm trying to look at the chat as well. All right, so let's delete the first node. So now we are going to have, just going to current us to the head. Yep, and that's because we're about to delete the head of the list. So what are we going to do? We're going to free something at some point, and we're going to return the head at some point. Yeah, we know that because that's how we defined it. Okay, so what are we feeling? What should we do now? So right now we've got a current head. We want to delete the head of the list and have the next thing be the head. So what do we think we're going to, what do we reckon we're going to do? That delay is killing me. Yeah, change the head to point to the next one. So my head is going to be head next. Excellent. And then what am I going to do? What am I going to free? So what will I cut? So my head is now sitting on the next node, and we can draw it up, don't worry, in a second. And I want to free the current node. Excellent, because that's the node that is storing the head in it. Yep. So I'm going to free that piece of memory and send it back to the heap. Okay, fantastic. So this should help. This should work to delete the first node in the list. Okay. So let's call it from our main and see that it works, and then we can draw a diagram to see where it's at. Okay. So delete first node. So we've got our print list. We've got something happening there, and let's call this delete first node, and we're going to give it the head of the list. And I'm going to print list, and tell me, is this going to give us the right output before I compile? Who reckons it's going to give us the right output? Everything is hunky-dory. The function's all good. Everything's good. What do we reckon? Tell you what, there's nothing better than coding in the rain. No, well done. Yes. So it's not going to be hunky-dory. I've just changed the head, And like yesterday, I haven't stored the head anywhere, the new head. So I'm going to make the new head, whatever is returned from my delete first node function, I'm going to store it inside this head, and then I'm going to print list the head. Okay, excellent. Let's save it, and let's work our magic. So I'm going to compile my .c files. And then I'm going to run it. Okay, so let's see what we have. Oh, you know, sometimes it's just, let's just do it again with a printf in there, just so we can see where the separations happen. Okay, one more time for good luck. Okay, so we had a list 11, 42, 13, and we wanted to delete the head, and we ended up with 42 and 13. So we did delete the head of the list, and we successfully returned what happened. The camera's in the way, my goodness. It's like totally in the way. There we go. How's that? Okay, so 4213, we've everything, we're doing great. Okay, now quick poll, because that was just curious. Do you want me to diagram this out? And you know what? Without asking it every time, I'm just going to go, do you want me to diagram every single piece of code that we do today? And it's now pouring with rain, which is actually quite nice. Okay, perfect. I mean, yes is winning wholeheartedly. Amazing. A few people are saying no. Sorry, but you're about to be a little bit bored as we draw our code and the diagram. Okay. So we are calling a function, and we are saying over here, head is equal to delete first node, and we're sending it with the head of the list. Excellent. Now my list, when I send it through, is composed of 11, insert, okay, 42. So the list right now looks something like this, the initial list, 11, 42, and 13. Okay, so we've got 3 nodes. The nodes are 11, 42, and I'm going to give them fake addresses, okay? Just because it might be easier for us to see what's going on. And 13. And here we have the head pointer. And it's got the address of my node in it. Okay, fantastic. So let's go to our implementation, and then we will, you know, I just made up my, it should probably be BBB, but I've made up the letters just, oh yes, and then it should be BBB because that's where yes. Good pickup, excellent. I'm pleased that someone's listening. Okay, excellent. We've come in here and we've gone to our first if statement, and we're checking is head is equal to null. So we are going to check if head is equal to null, and in my case, I've got head is equal to XXX. So head is not equal to null, which means I'm going to skip over this, and I'm going to move to line 129. Now in here, I'm going to create a new pointer variable, and that pointer variable is going to get the address of head in it. So it's going to get the XXX address in it. The next thing I'm going to do is I'm going to say, okay, find head next. So I'm going to go to head, which is XXX, and I'm going to go to the next. So I'm going to dereference it, which means that I am now looking at this node over here. Yeah. So head next is equal to AAA. And what I'm going to do, so I'm going to say that the new head is now whatever is head next. So that means that this is now going to be head next. So my AAA. The next thing I'm doing is I'm using free to free the current. Current is XXX. So when I free it, I'm going to remove this memory and give it back to the heap. And then what I will do is I'll return the head. So I'm going to return this AAA value back to the function that made the call. So that means when this returns, it's going to return the address AAA, and this head is going to get AAA stored in it. Okay, so that means what happened is I've successfully deleted the first node of the list, and the first node of the list is now the one that was the second node of the list. And then I've maintained the rest of the list because each node has the one after it. Okay, great. That seems to have worked. We're doing great. What about if I want to delete every single node in the list? What if I want to go through and delete every single thing? So I want to delete this, delete this, delete this, and basically just free it all up. Okay, I'm not happy with my linked list, not happy with its behavior. I'm done with linked lists. They're all overcooked. I would like to now free everything. Okay, so what happens if I want a function now? Let's expand this again. And I want a function to delete every node in my linked list. Okay, so that means I'm going to free all the memory of all the nodes. Yeah, so I'm going to have a while loop that's going to pulse through my linked list, and it's going to keep deleting